Hello, and welcome back to Mammalian Anatomy at Keuka College. Today what we're going to do is continue our conversation about Chapter 12, the nervous system, and continue our conversation about Part 3, the gross anatomy of the nervous system. Here we're going to look at the organization of the nerve, so how would the nerve look like if we dissected it? And something I would like you to be aware of is the organization of the nerve is going to be very similar to the organization of the muscle. And both of them are wrapped with connective tissue. And we're going to see that there are going to be still 3 layers of connective tissue. And it's still going to use the vocabulary of endo, peri, and epi. So let's look at the definition of nerve. So a nerve essentially is a bundle of parallel axons in the peripheral nervous system. Make a note of that. Nerves are in the peripheral nervous system. The equivalent term for the central nervous system is going to be a tract. Nerves can contain sensory, motor, or both types of neurons, and we're going to look at what types of neurons are in each nerve when we discuss the cranial nerves and the spinal nerves when we get to chapters 13 and 14. So nerves can also contain both myelinated and unmyelinated axons, so nerves are a bit of a mixture of different types of neuron types. So now that we understand the definition, let's look at the connective tissue that wraps around these neurons to form a nerve and understand the etymology a little bit more when we are using the vocabulary. So nerves are bundles of axons. So first thing that's going to wrap around an axon is going to be a Schwann cell. Schwann cells will wrap around all axons, regardless if it's myelinated or unmyelinated. It just depends on how the Schwann cell wraps around the axon. Then what's going to happen is that a piece of connective tissue is going to wrap around the axon plus Schwann cell. This deepest piece of connective tissue is called the endoneurium, and the endo in this word refers to within, and so it's going to be the deepest connective tissue that is going to wrap around the axon and Schwann cell. Neurium refers to the nervous system or the neuron, and so that's where we have these kind of root words and prefixes coming together to describe the connective tissue in an etymology sort of sense. Okay, so endoneurium is going to be the deepest. Then what we can do is we can take a bunch of these wrapped axons and bundle them together to form a fascicle, just like we have fascicles in muscles. These bundle of axons or fascicles are then going to be wrapped with another piece of connective tissue called the perineurium. Peri refers to around, so to wrap around. So that's essentially what this piece of connective tissue is doing. It's wrapping around a bunch of axons, forming a fascicle. From there, we can continue the bundling process by taking a bunch of fascicles and bundling them together with a third piece of connective tissue called the perineurium. The perineurium is going to be a very dense fibrous sheath that is going to wrap around this bundle of fascicles and form the nerve. If we're looking at the etymology of the perineurium, not perineurium, but the epineurium. Epi means upon, so it's going to be upon the outside of the nerve. So we have endo being the deepest, then we have peri coming next, and epi being on the most outside. This is going to be the same pattern that we saw when we looked at the organization of a muscle. Let's look at this these features on a diagram. So if you may, please follow my cursor. It is currently at the top by axon. So over here we have an axon, which is that long structure that is part of a neuron. And this axon is going to be wrapped with a myelin sheath. This myelin sheath is composed of 3 Schwann cells located here. And it's specifically going to be the myelin sheath because these Schwann cells are wrapped in a concentric rings or concentric kind of bundles. Even unmyelinated axons are going to have Schwann cells wrapping around them, but they're going to be wrapped around in a different way. Around the axon and the myelin sheath, we're going to have our deepest layer of connective tissue. This is going to be the endoneurium, and it will wrap around each of these axon myelin sheath kind of units. We can then take a bunch of these wrapped axons and form a fascicle. And this fascicle will then be wrapped with another layer of connective tissue called the perineurium, located here. Many fascicles will be bundled together along with blood vessels that will feed and nourish these cells of the nerve. And this whole entire structure will then be wrapped with a very thick, tough connective tissue called the epineurium. So the deepest is going to be endo, then peri, and then epi. So use your etymology to help keep it straight which connective tissue is located where. Thank you so much for listening, and I hope you have a wonderful day and be good to yourself. Bye-bye.